All right, these are the problems on page 245 that says section 5.8. And problem number 1 says 5/16 of 4/5 of the number is 15. Okay, so how do we do this? When you see of, it usually means multiply. So we're saying 5/16, there was an of, so we're going to multiply 4/5, and then there's another of, so we're going to multiply again, and we've got a number. Let's call the number x, okay? And then the is always means equal, so that's why I put the equal down. And then what comes after the equal sign? 15, okay? So of means multiply, is means equal. You can just say x is the missing number. Okay? Now, all we got to do is simplify this, and it's not so bad. Remember, these 5s are going to cancel out. 4 goes into 4 once, 4 goes into 16 4 times, and I end up with 1x over 4, which is just x over 4, is equal to 15. You could put the 1 out in front if you want to. If I want to solve for x, all I got to do is multiply both sides by 4, and I get x is 60. That wasn't too bad, was it? So just remember, of means multiply, and is means equal. Number 3 next. All right, if you look here, we get 30. Let's write it down. Then we see an is. Is means equal. Now I see 20% of 30% of the number, okay? Now these ofs are going to mean multiply. Now remember, when I do percents, I don't write down 20. I have to change that to a decimal. 20% is 0.2. So this 20% right here is going to be 0.2, and we're going to multiply it by 30%. Well, that's 0.220 for 20%, or 0.2. 30% would be 0.30. I'll just write 0.3, okay? And then we see another of, and then we've got a number. Let's call our number x, and let's solve for it. Well, this is easy now, because 0.2 times 0.3 would be 0.06 times x. And then if we divide both sides by 0.06, we'll have our answer. I'll let you finish this out yourself, but just divide 30 by 0.06 and you'll have your answer. And I'll let you get that. All right, on problem like number 5, this is a work problem. We got to think, okay, you got 2 pumps and they're working on the same job. The whole job we're going to represent with the number 1. That means the whole job got done. And so what we're going to do is we're going to describe how much of the work pump A did, and then we're going to add up the work that pump B did. They're working in the same amount of time, so we can describe how much work each one of them does in terms of how long they worked out of how long it would have taken them to work to do the whole job. So for instance, pump A, it's 30 hours to do the whole job, but it didn't work 30 hours. It only worked a certain amount of time. We'll call it T. Okay? Now we need to add in the amount of work that pump B did. Now pump B usually can do the whole job in 24 hours, but it didn't do the whole job. It just did part of it. And they started these pumps at the same time. Okay, they're running the same amount of time. So if we call T the time in both of them, I can just say however much time it was working out of 24. If I add these together, these are going to add up to 1. All right, you can see what we've got here is a fractional equation, and we want to, clear out the fractions and solve it. All right, now what number will 30 and 24 divide into? Now I could take time and see if there's a smaller number, but I happen to know, if you think about 24 times 10 is 240, right? Wouldn't 30 times 8 be 240? So if I get a common denominator of 240, I can tell that would work, okay? So there may be a smaller one, but I'm not going to worry so much about it. So I'm going to say, okay, I could clear the fraction by multiplying everything by 240, and that's what I guess I'll do. I could get a common denominator, but we've been talking about clearing out fractions, so let's just multiply everybody by 240. Okay? Now if I cancel out to, reduce these fractions, 30 goes into 30 once, it goes into 240 8 times. That would be 8t. Over here, 24 goes into 24 once, and 24 goes into 240 10 times, so that would be plus 10t. And then that's 240 on the other side. Well, 8t and 10t are 18t. 18t is 240. If I want to solve for the amount of time it took both of them to do it, all I got to do is divide both sides by 18. I'm going to let you divide that out on your own and get the answer. but the answer will be whatever we have 240 divided by 18. This kind of thing could show up on your SAT, by the way, and so it's a good, that's one of the reasons I assigned these problems, because I knew that they sometimes show up there. All right, if we look at problem number 7, it says how much pure antifreeze must be added to 12 liters of a solution of antifreeze to obtain a 60% solution. Okay. So what we've got is we've got this 12 liters, right, at 40%. And we're going to add some at 100%. And what we want to know, we're going to add some, we don't know how much we're going to add, right? We're going to put like X at 100%. When we get done, we want to have a 60% solution. All right, so let's think about this. I have 12 liters, and it's at 40%, so that's 0.40, okay? Now I'm going to add in some amount. We don't know what it is, but it's X, okay? It might be 5 liters, it might be 10 liters, who knows what it is. But it's at 100%. Well, isn't 100% just 1? Okay, if we write it as a decimal, because we wrote 40% as 0.4, so 100% would be 1.00 or 1. So now when we get done, we want to have a 60% solution. Well, how much liquid do we have now, or how much antifreeze total? Well, we started with 12 liters, but we added in X liters, and we don't know what it is, but we can figure it out now. If I do this, I can say, okay, this is my equation. It's what I started with plus what I'm adding in at 100% antifreeze, and this is going to be a 60% at the amount that I had plus the amount that I added. All right, so 12 times 0.4 would be 48. BC 480, but 2 decimal, no, 4.8. Be 4.8, wouldn't it? Okay, plus X equal, on the other side, 60 times 6.60 times 12 would be 7.2. And then I'd have 0.6 times X, so it'd be 0.6X. Now, if I don't like all these decimals, I can get rid of them. What if I went through and I multiplied every single one of these numbers by 10 on both sides? Wouldn't that just move the decimal place over 1 digit? That would make it 48 plus 10X, since I got to multiply there, would be 72 plus 6X. Now, if I want to get all my X's together, we can move our X's over here. And we get 48 plus 4X is equal to 72. And then we could subtract 48 from both sides. And we get 4X equals to 24. And if 4X is 24, and we divide both sides by 4, we find out X is 6. Oh, we added in 6 liters to get it at a 60% solution. Okay, problem number 9, you have a riverboat, and it goes upstream, and it's going at a speed or a rate of 12 kilometers per hour, so I put R equal 12 kilometers per hour. And then so it goes upstream, and then it stops for 2 hours of sightseeing. So it's going a certain distance, and it's stopping, and then it's coming back. Now, we could say that the time, if we call the upstream part time T, then it stopped for 2 hours. That would give us the total amount of time it went until it stopped and turned around and came back. So let's think about it. It goes upstream, plus then it stops for 2 hours. And then it comes back downstream is kind of what's going on. Now, they tell us the total time is 7 hours. And what they want to know is how far did it go. All right, now I've been trying to write down everything it says, but I'm kind of getting stuck. So let me think. There is a formula, and it's distance equal rate times time. Okay. Now, if I wanted to, one thing I know for sure is that the distance upstream is equal to the distance downstream. Okay? Now, what is the distance upstream? It is its rate times its time. So let's say its rate is 12 kilometers per hour, and its time is t. So now we'll call time going up t, okay? Now it comes back downstream, and we know what its rate is. We're going to say we want the distance downstream. That's going to be its rate times its time. Well, what was its rate? It was 18. And what was its time? I don't know. It was 7 hours minus 2 hours that it stopped minus whatever the t was that it took to get upstream. Because it didn't, the thing about this is when you're setting it up, when it was going upstream, it only went upstream for a certain amount of hours, and then it stopped. So we don't want to multiply the rate times that time it was stopped, because it was going 0 while it was stopped, right? But if we know the two distances are equal, we know that we could describe it this way, because if you look at the distance downstream, if we want to simplify that expression, 7 minus 2 would be 5 minus t. So we end up with 12t is equal to 18 times 5 minus t. Well, 12t would be 18 times 5 is 90 minus 18t. So if I move this over here, if I add 18 to both sides, this would be what? 30t is equal to 90, and t is equal to 3. Now that tells me the time it was, what t is, right? But what did they want to know? They wanted to know how far it went. So we now know something. We know how far it was paddling. It was paddling for 3 hours upstream. So if I want to know how far it went, I could go, well, upstream, we know that time is 3. We solve for it. And distance is rate times time. Well, what was the rate upstream? It was 12. What was the time that we found? It was 3. Oh, it was 36 kilometers is how far it went upstream. So what we did is we described, we had to describe our distance in terms of the rate upstream and the rate downstream. So each distance had to get described that way. And then we had to talk about the time that it went going upstream and downstream.